Imagine staring at a piece of medical paperwork that holds a word practically invented yesterday.
Right.
A diagnosis so ultra-rare that, out of the 8 billion people on Earth, only a few hundred share it.
Yeah, it's staggering.
You are likely sitting somewhere right now, maybe at your kitchen table after the kids are finally asleep, or maybe in a sterile hospital cafeteria with the hum of the vending machine in the background, just staring at that string of letters. PURA syndrome. PURA.
It's an incredibly heavy moment.
It really is. If you are listening to this, chances are you are a parent or a carer, and that piece of paper has probably turned your entire universe completely upside down.
And we want to start by just, well, acknowledging the absolute whirlwind of emotions you are sitting with right now. Receiving a rare genetic diagnosis for your child is a trauma.
Oh, absolutely.
It brings an intense, immediate wave of fear.
There is confusion because the medical jargon alone feels like an impenetrable wall.
Yeah, it's like a different language. Exactly. There is profound grief for the neurotypical path you thought your child was going to take. And perhaps, heaviest of all, there is a crushing sense of isolation. That feeling that you are the only person on the planet dealing with this specific, terrifying unknown.
That response is entirely valid. But our specific mission for this deep dive today is to shatter that isolation.
That's the goal.
Consider this your welcome to the family because you are not alone. We are taking the massive stack of sources in front of us, the dense clinical guidelines, the latest medical research up to 2026, genetic papers from institutions like the Florey, and updates from the PURA Syndrome Foundation, and we are going to decode all of it.
Every single piece.
Right. If getting this diagnosis feels like being dropped out of a plane into a foreign country where you don't speak the language, you have no map, and all the locals speak entirely in medical acronyms, well, we are going to be your translation guide and your compass.
And my role here is to be your calm guide through the biology and the medicine. Because while the path ahead of your family is undeniably unique, there's a concrete, rigorously studied scientific roadmap waiting for you.
It's not just a blank map anymore.
No, not at all. This diagnosis is the start of a new, deeply meaningful journey. It is not the end of a happy life. There is a global family waiting to embrace you, and there is a brilliant scientific community working around the clock on your behalf.
So to figure out where we are going, we first have to understand the piece of paper in your hand. Let's look at the microscopic root of the syndrome.
Okay.
What exactly is PURA, and why does it feel like nobody, sometimes not even your local pediatrician, has ever heard of it?
It feels like nobody has heard of it because, well, in the grand timeline of human medicine, it was practically discovered yesterday. Up until October of 2014, this condition didn't even have a name.
Wait, 2014?
Yes. For decades, families were wandering in the dark on what geneticists call the diagnostic odyssey. That means going from specialist to specialist year after year, enduring invasive tests, only to be told, we don't know why your child has these delays.
That must have been agonizing, just living with the reality of the symptoms, but having no blueprint for what was causing them.
It was incredibly isolating. But then a transformative shift happened in late 2014. Teams led by brilliant researchers like Dr. David Hunt in the UK and Dr. Seema Lalani in the US utilized advanced whole exome sequencing to connect the dots.
Oh.
Yeah, they published the very first clinical papers recognizing PURA syndrome as a distinct genetic condition. So if your child is diagnosed today, you have to realize that you are part of a pioneer generation.
2014, I mean, just to put that in perspective, that's when we were all doing the ice bucket challenge on social media. That is incredibly recent history. So let's open up this genetic blueprint. Looking at our sources, PURA is described as a gene located on chromosome 5, specifically at the locus 5q31.3. But the phrase that really jumps out at me is single-exon gene, because most genes have multiple exons, right? So why is a single exon gene so vulnerable?
To understand that, we need to look at how DNA is normally structured. You can think of a typical gene like a textbook. The important information, the actual text you need to read, is broken up into chapters.
Yeah.
In genetics, those chapters are called exons.
Okay, chapters are exons.
But between those chapters, there are dozens of blank pages. Those are called introns. When your body reads the textbook to build a protein, it skips over all those blank pages and just splices the chapters together.
So if there's a typo or an ink spill on one of those blank intron pages, it doesn't really matter. The body just skips it anyway.
Precisely. It provides a massive buffer against random genetic errors. But the PURA gene is a structural rarity. It is a single exon gene.
Meaning no blank pages?
Zero. It is one long, continuous, critical paragraph of densely packed biological information.
Which means it's like a critical line of code in a computer program that has absolutely no backup. Even a tiny typo, like one wrong letter, causes a massive system reboot because there's no buffer to absorb the mistake.
That is the perfect way to visualize it. There's no room for error. The sequence integrity of the PURA gene has to be pristine, and the code in that continuous paragraph provides the instructions for making a very specific protein called Pur-alpha.
Okay, let's talk about Pur-alpha. What does this protein actually do in the body?
It's a biological multitasker made up of 322 amino acids. While it's found across almost all human tissues, your heart, your skeletal muscle, your blood, its role is most profoundly felt in the central nervous system.
In the brain.
Exactly. In the developing brain, Pur-alpha acts as a master regulator. It controls DNA replication, it regulates how neural cells multiply, it helps the branches of the brain cells, the dendrites, mature. And it is absolutely essential for forming synapses, which are the communication bridges between neurons.
So it's basically the foreman on the construction site of the developing brain. It's walking around with the clipboard telling the cells when to divide and where to build the bridges.
That's a great analogy. And to do that job, the Pur-alpha protein has a very specific physical shape. We can break it down into 3 parts. At the beginning, it has a flexible, glycine-rich N-terminus, which acts like a hinge so the protein can adapt and bend.
Okay.
At the end, it has a C-terminus that interacts with other proteins on the construction site.
Yeah.
But the most important part is in the middle.
The middle section. Sources call these the Pur repeats. Repeat 1 and 3.
Yes.
Yeah.
Think of those 3 repeats like the 3 prongs on a mechanical claw machine.
Yeah.
Their specific job is to reach out and physically grip onto single and double-stranded DNA and RNA.
Oh, wow.
Yeah, that grip is how the foreman reads the blueprints and tells the construction site what to do.
Okay, so when a child is diagnosed with PURA syndrome, there is a mutation somewhere in that structure. Our sources mention a very common mutational hotspot called the P233del variant.
Right, that's a common one.
Let's decode that for the listener. What does that string of letters and numbers actually mean for our claw machine?
Let's break it down. The P stands for protein. Phi stands for phenylalanine, which is one of those 322 amino acids. 233 is the exact position in the chain. And del stands for deletion.
So at position 233, one single building block is missing.
Just one. But because it's missing, the entire structure of per repeat 3 is distorted. To use your metaphor, the mechanical claw machine is suddenly missing a spring on its 3rd prong.
So it drops down but can't close.
Exactly. The claw drops down, but it can't close properly. The protein can no longer bind to its target nucleic acids effectively. It can't grip the blueprints.
But wait, don't we inherit 2 copies of every gene? One from our mother and one from our father?
We do.
So if one copy has this typo, shouldn't the other healthy copy be able to manufacture enough healthy claw machines to get the job done?
You would hope so, but this is where a concept called functional haploinsufficiency comes in. Haplo means half. Insufficiency means not enough. For some genes in the human body, having 50% of the normal protein production is perfectly fine. You can survive on half. But Pur-alpha is so critical to the brain's architecture that 50% is simply not enough.
Ah, I see.
The foreman is trying to build a massive skyscraper, but he only has half the workers he needs. The brain simply cannot build itself properly on half a tank.
I want to pause right here because we just talked about inheriting genes, and I know exactly where a parent's mind goes the second they hear the word genetic. We need to talk about parental guilt.
Yes, absolutely.
Because the immediate agonizing thought is, what did I do wrong? Did I eat the wrong thing? Did I have a glass of wine before I knew I was pregnant? Is my DNA broken and I pass this on to my baby?
I am so glad we are stopping to address this because we need to shut that guilt down immediately. The medical literature is incredibly definitive on this point. The vast majority of pathogenic variants in PRA are what geneticists call de novo mutations.
De novo, meaning anew or from the beginning.
Yes, they happen completely spontaneously. To understand how, you have to think about gametogenesis, the creation of the egg or the sperm. When human cells divide to create reproduction cells, they have to copy 3 billion letters of DNA.
3 billion?
It is a staggering biological undertaking. Every so often, the cellular machinery simply makes a random spelling mistake. It inserts a letter or deletes a letter just by pure chance.
So it's not inherited from the parents. The parents' blood DNA is completely typical.
Completely typical. The mutation occurred as a random biological roll of the dice in that one single sperm or that one single egg or in the very first few cell divisions after conception.
Wow.
It is absolutely not caused by anything a mother ate, drank, did, or thought during pregnancy. It is not a consequence of stress. It is an unavoidable, spontaneous event of human biology.
That is so profoundly important for you to hear. You did not cause this.
You did not cause this. And furthermore, because these are almost exclusively de novo events, the recurrence risk, meaning the chance of you having another child with PURA syndrome in a future pregnancy, is incredibly low. It is typically less than 1%.
Less than 1%. Why isn't it absolute zero?
The only reason geneticists don't say zero is due to a very rare phenomenon called germline mosaicism. This is a situation where a parent's blood tests show normal DNA, but a tiny hidden cluster of their reproductive cells deep in the ovaries or testes carries the mutation. But statistically speaking, the risk of recurrence is negligible.
Okay, so if this is a random spelling mistake that just happens by chance at the dawn of cell division, how often does that biological dice roll actually land on PURA? Let's talk about the numbers. How rare is this club our listener just joined?
The numbers are staggering. As of late 2024, the Global Patient Registry and the medical literature had identified about 706 confirmed cases worldwide.
Just 700.
Yes. Now, as we move through 2025 and into 2026, with better diagnostic tools becoming available, that estimate is pushing towards 750 to 800 patients globally. When epidemiologists run the math, the estimated incidence is roughly 1 in 1 million people.
1 in a million. Literally.
Literally. Now, that number is likely an undercount. There are many older individuals living in care facilities with generic diagnoses of cerebral palsy or intellectual disability who actually have PRA, but they grew up in an era before whole exome sequencing existed.
Right, they just missed the technology window.
Exactly. And in developing nations without access to advanced genetic testing, many children remain undiagnosed. But even if we double or triple the known cases, it remains an ultra-rare disease. You are in a rare club, but you must remember the second half of that sentence. You are absolutely not the only one.
Which brings us to the reality of those early days, because knowing that this genetic hardware issue was present from the literal moment of conception directly explains the terrifying first days or weeks of your child's life.
Yes, it does.
We need to transition from the DNA level to validating the traumatic neonatal intensive care unit, experience the NICU that you likely just survived.
And survived is the right word. The clinical manifestations of PURA syndrome don't wait for the child to grow up. They're typically present from the moment of birth, often appearing as an acute, terrifying medical crisis.
What are the main signs?
The literature defines the neonatal presentation by a very specific triad of symptoms. Over 95% of these babies experience severe neonatal hypotonia, which is profoundly low muscle tone.
Floppy baby syndrome.
Exactly. Over 50% face life-threatening respiratory insufficiency, meaning they can't breathe on their own, and over 80% have significant feeding difficulties.
I want to dig into the hypotonia, because this is where the mechanisms really matter. The sources describe this as central hypotonia, not peripheral. So it's not that the muscles in the baby's arms and legs are broken or degrading, right? It's more like the brain's Wi-Fi signal telling the muscles to move is just too weak.
That distinction is exactly what neurologists have to figure out in the NICU. Let's compare it to a peripheral neuromuscular disorder, like spinal muscular atrophy, or SMA.
Okay.
In SMA, the motor neurons in the spinal cord are actively degrading. The physical wire connecting the spinal cord to the muscle is breaking. But in PURA syndrome, the hypotonia is central in origin. The muscles themselves are healthy.
The muscles are fine.
The peripheral nerves are fully intact. But the brain, lacking that crucial Pur-alpha protein foreman, is failing to send a strong, coordinated Wi-Fi signal down the spinal cord to tell those muscles to contract and hold tension.
But wait, hold on. If the brain's Wi-Fi signal to the muscles is weak, how does a doctor in the NICU actually prove that before the genetic test comes back? Because sequencing takes weeks. If the baby is completely floppy, wouldn't all their reflexes be gone too?
That is the brilliant part of the neurological exam. They look for clues in the reflex arc. You see, when a doctor taps your knee with a little rubber hammer, that signal doesn't actually travel all the way up to your brain to ask permission to kick.
It doesn't.
No, it travels just to the spinal cord, and the spinal cord instantly fires back the command to kick. It's an automatic loop that bypasses the brain entirely.
So because PURA is a problem in the central brain, the spinal loop still works.
Exactly. Unlike babies with SMA who have profound orthorexia, meaning they have absolutely no reflexes because the spinal wires are broken, Infants with PURA syndrome typically have preserved deep tendon reflexes.
That's
You
fascinating.
tap the knee of a floppy PURA baby and there's a response. That tells the neurologist immediately, okay, the peripheral circuitry is intact. The problem is higher up in the central nervous system.
So the doctor knows the problem is in the brain, but there are other conditions that cause central hypotonia, right? Like Prader-Willi syndrome. How do they rule that out?
They look at the physical phenotype and the behavioral progression. Babies with Prader-Willi have very specific facial features and genital hypoplasia that aren't typical of PURA. And crucially, while Prader-Willi babies start out floppy, they eventually develop an insatiable, extreme, pathological hunger as toddlers.
Oh, I see.
Yeah, that hyperphagia does not happen in PURA syndrome.
Right. In fact, it's the exact opposite. Instead of extreme hunger, babies with PURA have extreme difficulty just getting a few ounces of milk down. The clinical term in the sources is dysphagia.
Yes, the feeding difficulties are almost ubiquitous. And again, it all comes back to that central hypotonia and a weak Wi-Fi signal. We take swallowing for granted, but it's not just one muscle.
It's a whole process.
It is an incredibly complex, highly coordinated sequence called the suck-swallow-breathe cycle. It involves cranial nerves, the tongue, the throat, the esophagus, and the airway, all dancing in perfect rhythm. If the brainstem cannot coordinate that sequence, the baby is at a massive risk of aspiration.
Aspiration meaning inhaling liquid into the lungs.
Yes, milk goes down the trachea instead of the esophagus. This introduces bacteria into the lungs and causes aspiration pneumonia, which can be fatal for a fragile neonate.
And because of that danger, the sources are very clear that many neonates require immediate nutritional support. They start with nasogastric tubes and G tubes threaded down the nose. And often, they progress to the surgical placement of a gastrostomy tube, a G tube, which goes directly through the abdomen into the stomach. I want to slow down here for the parents listening, because getting a feeding tube for your baby is rarely just a medical decision. It is an emotional crisis.
It really is.
It is often accompanied by this immense, crushing sense of failure. Like, I am a mother, I am a father, and I couldn't even do the most basic, primal, biological task of feeding my own baby.
It is a profound grief. Medical professionals hear this from families constantly. But we need to reframe this completely. A G-tube in the context of PURA syndrome is absolutely not a failure of parenting.
Not at all.
It is a vital, life-saving bridge.
A bridge.
Yes. It ensures your child gets the guaranteed, stress-free caloric intake they desperately need to grow their brain and body. It protects their fragile lungs from pneumonia. Most importantly, it takes the terror out of feeding time.
Which is huge for the parents' mental health, too.
Exactly. Instead of spending an hour fighting through choking episodes, watching your baby turn blue and crying from the stress, a G-tube allows you to actually sit and bond with your child. You can cuddle them, read to them, and just be a parent while the machine does the mechanical work of delivering calories.
It's shifting the perspective from my body failed to medical science is giving me a tool to keep my baby safe.
Exactly right.
Now, alongside the feeding issues, the respiratory distress in the NICU is another major trauma. The sources say more than 50% face apneas. And just like the hypotonia, there are different mechanisms at play here.
Correct. We have to differentiate the types of apnea they experience because both are caused by the condition but require different management. First, they experience obstructive sleep apnea.
What causes that?
This happens when the child falls asleep, the muscles relax, and because they already have low tone, the tissues in the oropharynx, the back of the throat, physically collapse and block the airway.
That sounds terrifying, but at least it's a mechanical blockage you can treat with positioning or a CPAP machine. But the sources point out something much more concerning: central apnea.
Central apnea brings us right back to the brain's Wi-Fi signal. The Pur-alpha protein is heavily expressed in the brainstem, which is the primitive lizard brain part of your central nervous system that controls automatic unconscious functions.
Like breathing.
Yes. You never have to think about breathing. Your brainstem just does it. But in central apnea, the brainstem simply forgets to provide a consistent drive to breathe. The electrical signal to the diaphragm just drops out.
The baby just stops trying to breathe.
Precisely. This is why these babies frequently require mechanical ventilation or supplemental oxygen in the NICU. It's also why they suffer from hypothermia, which is severe temperature instability.
Because the brainstem controls that too.
Right. The brainstem is the body's thermostat, and if it's struggling to signal the lungs, it's also struggling to maintain body heat. You'll also see hypersomnolence, which means excessive sleepiness. The baby is so neurologically exhausted that they struggle to wake up and engage with the world.
Hearing all of this, I mean, the feeding tubes, the brain stem forgetting to breathe, the temperature drops, it is overwhelming. If a parent is listening to this in the NICU right now, it feels like a mountain they can't climb.
It really does.
But there is a massive, beautiful ray of hope embedded deep in these clinical guidelines regarding the breathing, isn't there?
There is an incredible ray of hope. While the respiratory issues in the first year of life are terrifying and require intense medical support, longitudinal studies and the natural history of the disease show something remarkable.
What's that?
These apneas frequently show a gradual, significant improvement, and in many cases, completely resolve after the child turns 1.
Wait, really? Just by getting older?
Yes. As the brain matures, even with the deficit of the Pur-alpha protein, it begins to adapt and compensate. The neural pathways strengthen. The brainstem gains better autonomic control.
Wow, so it actually gets better.
It does. Many individuals will still require nocturnal monitoring like a pulse oximeter strapped to their toe at night just to be safe, but the acute, life-threatening respiratory crises of the newborn period very often stabilize.
That is exactly the kind of knowledge that gives you the strength to get through another night in the NICU, knowing that the respiratory trajectory gets better.
Absolutely.
So let's look further down that road. As your child grows past those acute physical crises of infancy, the challenges shift. You move from basic survival to interaction, development, and learning. And this is where we have to tackle the labels that traditional medicine uses because they can be devastating.
And those labels are often applied with a very broad, very harsh brush.
Incredibly harsh. Because if a toddler is nonverbal and they have profound motor delays where they aren't walking or sitting up, the medical chart often just slaps on a label of severe intellectual disability or global developmental delay.
Right.
But when you talk to the parents of PURA children, they consistently say otherwise. They see a spark in their child's eyes, they see humor, they see understanding. So what does this actually mean for their intelligence? Are our standardized medical tests just failing to measure a mind that is trapped inside a body that won't cooperate?
If we connect this to the bigger picture of neurodevelopment, we have to look at a concept known as the receptive-expressive discrepancy. I want every parent listening to hold on to this concept because it is arguably the most vital insight in our entire deep dive today.
Let's break that down. Receptive versus expressive.
One of the most profound universal aspects of the PURA phenotype is the severe impairment of expressive language. The vast majority of individuals with PURA syndrome are non-speaking. They remain unable to produce meaningful spoken words throughout their lives. Their oral motor hypotonia, combined with a neurological planning deficit, means their mouth cannot form the words.
And traditionally, a doctor sees a child who cannot speak, and they equate that with an inability to think or understand.
Which is a tragic, archaic misconception. A hallmark of PURA syndrome, explicitly noted and validated in the recent medical literature, is the massive discrepancy between what they can express and what they can receive.
Meaning what they understand.
Exactly. They have a surprisingly high level of receptive language. Parents and clinicians report that these patients demonstrate a deep, nuanced level of understanding. They can follow simple commands and sometimes highly complex multi-step instructions. They track conversations. They understand jokes. They know exactly what is going on around them. They understand you.
They just can't get the words out. It's like being a brilliant prisoner trapped in a cell, tapping Morse code on the wall, but nobody on the outside knows how to listen.
That is a heartbreakingly accurate way to describe the frustration they must feel. The cognitive delay is absolutely present. We cannot minimize that. They do learn slower. But the expressive barrier makes their intelligence look far lower than it actually is on the inside.
Which changes how you approach therapy.
Completely. This is why the early, aggressive implementation of augmentative and alternative communication AAC is not just a nice bonus therapy. It is a critical medical necessity. You have to give them the keys to the cell.
What kind of AAC are we talking about for a child with PURA? Because you can't just hand them an iPad if their motor skills are also severely delayed.
Exactly. It has to be highly individualized by a specialized speech-language pathologist based on the child's specific motor control. The sources outline a progression of strategies. For some families, manual signing works beautifully.
Like ASL.
Not complex American Sign Language, but simplified gestures like keyword sign, where they learn to sign more, eat, or finished.
But what if they don't have the fine motor control in their hands to make those signs?
Then you move to low-tech options. Symbol-based boards or communication books. The child uses whatever gross motor control they have, a fist, an elbow to point to a picture of a cup if they want to drink, or a picture of a park if they want to go outside.
And as technology improves, we get into the high-tech solutions.
Yes, touchscreen devices with dynamic display software. And here is where it gets truly miraculous. For children with severe motor limitations, kids who perhaps can't reliably isolate a finger to point, or who struggle to hold their head up, but who have intact visual tracking.
Yeah.
Advanced eye gaze technology is an absolute game changer.
How does eye gaze actually work?
It uses an infrared camera mounted below a screen. The camera tracks the exact reflection on the child's cornea. The child simply looks at a symbol on the screen, say, a picture of their dog, and if they hold their gaze there for a fraction of a second, the computer selects it and speaks the word out loud. They can build entire sentences just by moving their eyes.
That gives me chills. Unlocking a mind just through their gaze. And the goal here isn't just functional, right? The goal isn't just letting them say, I'm hungry or my stomach hurts. The goal is social connection.
Absolutely. Because the behavioral profile of children with PURA syndrome is overwhelmingly positive. Across all the case studies in the literature, they're widely described by researchers and families as incredibly social, loving, friendly, and deeply affectionate.
They want to interact.
They want to be part of the joke. Providing them with a voice through AAC reduces their frustration. And when you reduce frustration, you dramatically reduce behavioral challenges like self-injury or severe anxiety that can crop up when a smart kid is trapped without a way to communicate.
Okay, so we unlocking their voice. What about their physical development? The motor milestones like sitting, crawling, walking.
This brings up another crucial, comforting fact that separates PURA from some of the most feared genetic diagnoses. PURA is not a degenerative disease.
I want you to say that again because that is a massive sigh of relief for a parent who might be Googling rare diseases and finding horrors.
I will say it again. PURA is not a degenerative disease. Your child will not learn a skill and then lose it.
That is wonderful news.
It is. There is no biological ticking clock destroying their muscles. The progress is slow, sometimes agonizingly slow, but it is always moving forward. Motor milestones are significantly delayed. Independent walking is not guaranteed for everyone, but for those who do achieve it, it might not happen until age 3 or age 5 or even age 10.
And when they do walk, the sources describe it as a wide-based gait.
Yes. Because that central hypotonia, that weak Wi-Fi signal, is still a factor, their balance is compromised. They walk with their feet wide apart for stability. They are unsteady, and they are prone to falls. They're constantly fighting gravity with a slightly weaker signal from the brain.
Which means physical and occupational therapy aren't just about learning to walk.
Right. Therapy from infancy is essential not to cure the hypotonia, because you can't exercise away a genetic protein deficit, but to maximize their functional capacity. You are training the neural pathways that do exist to be as efficient as possible.
Like rewiring the house.
Exactly. And therapists are vital for getting the child fitted for the right durable medical equipment. Walkers, gait trainers, ankle-foot orthotics to support floppy joints, and customized seating systems so they aren't exhausting all their core energy just trying to sit up straight.
Okay, so let's take a step back and look at the whole picture. As your child grows, you are navigating speech therapy, physical therapy, eye gaze devices, feeding tubes, walkers. It sounds like managing PURA is like being the general contractor on a complex house build, but none of your subcontractors, the plumbers, the electricians, the roofers are talking to each other. You, the parent, have to hold the master blueprint.
That is the perfect analogy for the project manager phase of parenting a child with a complex, rare disease. Because the Pur-alpha protein is expressed everywhere in the body, PURA is a multisystemic condition. It affects everything.
Right.
And our medical system is highly siloed. The gastroenterologist doesn't always talk to the neurologist. You have to become a fierce, highly educated medical advocate.
And looking at this blueprint, the heaviest burden, the room in the house that requires the most aggressive management, seems to be the electrical system, the epilepsy.
It is the most daunting medical hurdle after the NICU phase.
Yeah.
The neurological burden of PURA is severe. Over 50% of individuals with PURA syndrome develop complex, hard-to-treat epilepsy.
When does that usually start?
The onset typically occurs a little later, usually between the ages of 2 and 5, though it can certainly start earlier in infancy or later in childhood. And what makes it particularly challenging is that it often evolves over time.
Evolves how? Do the seizures change shape?
Yes. Many patients begin with what are called myoclonic jerks. These are brief, sudden, involuntary muscle twitches. It might look like a sudden shiver or a dropping of the head.
That sounds like it could be subtle.
It can be.
Yeah.
But they can be very frequent and incredibly disruptive to learning. Over time, as the brain grows and the neural networks become more complex, these may progress to more severe types of seizures, including generalized tonic-clonic seizures.
Those are what people traditionally picture when they hear the word seizure, right? The convulsing and loss of consciousness.
Correct. And in some cases, the epilepsy evolves into a specific, highly feared diagnosis called Lennox-Gastaut syndrome.
I know we need to take a breath here. Lennox-Gastaut is an extremely heavy diagnosis. Let's explain what it is, gently but honestly.
It is an epileptic encephalopathy. It is characterized by multiple different types of seizures happening in the same child. And crucially, it is refractory, meaning it is highly resistant to standard anti-seizure medications.
So the meds just don't work.
Often they don't. Furthermore, Lennox-Gastaut is a known predictor of developmental plateauing. If the brain is constantly fighting electrical storms, it cannot process new information or solidify memories.
And because the genetic defect in PURA is present throughout the entire brain, you can't just do a brain scan, find the one spot causing the seizures, and surgically remove it.
Exactly. It is a generalized network problem, not a focal lesion. So families are forced into a grueling trial and error process, cycling through multiple powerful anti-seizure medications in combination, trying to find a cocktail that reduces the seizures without turning the child into a zombie from the side effects.
But the research isn't stagnant here. There's a fascinating case study in our sources about a completely different approach, a real beacon of hope for epilepsy management in PURA. Let's talk about the ketogenic diet.
This is a vital avenue for treatment that parents need to be aware of. The journal Genes published a very detailed case report recently about an 11-year-old boy with PURA.
Okay, what was his situation?
He had a specific de novo frame shift variant, C.39947 at or dilabub, which basically results in a premature stop sign when the body is building the Pur-alpha protein. He had severe intellectual disability, tetraparesis.
Wait, let's define tetraparesis. Tetra means four, paresis means weakness.
Exactly. Yeah. Profound weakness in all four limbs. And at age 7, he developed highly refractory seizures. He was having up to 30 flexion spasms a day, dropping his head and losing consciousness.
30 a day, every single day. That is devastating for a child's developing brain. You can't learn anything if you're being electrically reset 30 times a day.
It's catastrophic. Standard anti-seizure meds like valproate and levetiracetam either caused severe behavioral side effects or simply failed to stop the storms.
What did they do?
His medical team decided to initiate the ketogenic diet. Now, I want to be very clear. We are not talking about the internet weight loss fad.
Right. This isn't just cutting out carbs to trim down.
No. In neurology, a strict, medically supervised, high-fat, low-carbohydrate diet is a profound metabolic intervention.
How does it actually work in the brain?
When you starve the body of carbohydrates, it can no longer use glucose for energy. The liver is forced to break down fats into molecules called ketones. The brain then uses these ketones for fuel.
Okay, so it changes the fuel source.
Exactly. Ketones fundamentally alter how the mitochondria, the power plants of the cells, function. They bypass certain metabolic pathways and increase the production of GABA, which is the brain's primary calming inhibitory neurotransmitter. It physically alters the excitability of the neurons.
And what happened to this 11-year-old boy on the diet?
The response was dramatic. The diet didn't just significantly reduce his seizure frequency, it also unexpectedly resolved another severe chronic symptom he struggled with: profound coeluria.
Coeluria, that's the medical term for excessive drooling, right?
Yes. Because of their central hypotonia, children with PURA have poor swallowing control. They produce normal amounts of saliva, but they don't automatically swallow it away, leading to constant severe drooling, which causes skin breakdown and social stigma.
And the diet helped with that too.
It did. This was the first documented clinical case showing incredible improvement in both refractory seizures and coeluria in a PURA patient using the keto diet.
That is massive. It proves that even when the standard pharmaceutical toolbox fails, there are alternative, highly effective biochemical therapies out there.
Yes, there are always other options to explore.
But as the medical project manager, a parent also has to be incredibly vigilant because not every abnormal movement a child makes is a seizure.
This is a critical distinction, and it's why serial EEGs, brainwave tests, and video telemetry are so important. Children with PURA frequently exhibit non-epileptic movement disorders. These look scary, but they aren't electrical storms in the brain.
For instance?
Well, they experience dystonia and dyskinesia.
What do those look like?
Dystonia is a sustained or twisting involuntary muscle contraction. A foot might cramp and turn inward, or the neck might pull to one side. Dyskinesia is more flowing, writhing, involuntary movements. They also frequently display stereotypes.
Like repetitive hand flapping or rocking.
Yes. Hand flapping, finger flicking, or sometimes hand biting. These are very common in children with severe intellectual disability or autism. They are not seizures. They are self-stimulatory behaviors used as a sensory regulation tool when the child is overwhelmed or excited.
And there's one more specific reflex mentioned in the sources that parents should watch for, something called the pathological startle response.
The clinical term is hyperacusis. It's an exaggerated, prolonged physical reaction to a sudden acoustic or tactile stimulus. A door slams down the hall, or a dog barks, and the child has a massive, sustained physical startle that lasts much longer than a typical person's jump.
Oh, wow.
In fact, observing this pathological startle response in a hypotonic child with developmental delay is now considered a red flag clinical indicator that should prompt a geneticist to test specifically for PURA syndrome.
Okay, so the brain and the nervous system are obviously the main contractors on this job site. They demand the most attention. But to finish our project manager blueprint, what about the other systems? What else does a parent need to monitor?
Let's start with the structural framing. The skeletal system. Because the child has chronic hypotonia, they are often non-ambulatory, meaning they use a wheelchair. They aren't engaged in dynamic, weight-bearing activities like running and jumping.
And bones need that stress to grow strong, right? The impact tells the body to deposit calcium.
Exactly. It's called Wolff's Law. Without that mechanical stress, the bones and spine don't get the signals they need to grow strong and straight. As a result, scoliosis, a severe, progressive S or C-shaped curvature of the spine, is reported in about 48% of the PURA population.
Almost half. And our sources even include a specific case report of a 15-year-old girl in Poland with PURA who required major spinal fusion surgery to stabilize her scoliosis because the curve was actually compressing her thoracic organs and making it hard for her to breathe.
Precisely. You have to monitor the spine constantly. They also frequently suffer from hip dysplasia, where the hip socket doesn't fully cover the top of the thigh bone, leading to dislocation. And crucially, you have to monitor bone density.
Why is that?
Many individuals with PURA demonstrate osteopenia or osteoporosis, which is low bone mineral density.
Which means their bones are brittle.
Yes. This leads to pathological fractures. A bone might break during completely normal low-impact activity or during a physical therapy stretch. So regular DEXA bone density scans and aggressive vitamin D and calcium supplementation are essential components of their care.
And if they do need surgery, say spinal fusion for that scoliosis or the placement of a G-tube or orthopedic surgery for hip dysplasia, there are incredibly specific, strict rules about anesthesia. This is literal life or death detail for parents to know and advocate for.
If you take away absolutely nothing else from the medical management section today, remember this. You must download and print the Orphan Anaesthesia guidelines for PURA syndrome.
Print them out and take them with you.
Yes. Because of their central hypotonia and their underlying brainstem dysfunction, these patients have an extreme atypical sensitivity to sedative medications. Furthermore, they have a severely delayed recovery from respiratory depressants.
So the anesthesiologist cannot just look at a 10-year-old with PURA, check their weight, and give them the standard dose of anesthesia for a 10-year-old.
Absolutely not. That could be catastrophic. The guidelines explicitly mandate a 50% reduction in the initial doses of opioids and benzodiazepines during induction. And because of the massive risk of central and obstructive apnea after the breathing tube is removed, day surgeries or ambulatory surgeries are strictly contraindicated.
Meaning no going home the same day, ever.
Never. A child with PURA having a tooth extracted under general anesthesia requires the same post-op vigilance as major surgery. Any procedure requiring general anesthesia mandates a minimum 24-hour inpatient hospital admission. They require continuous pulse oximetry and respiratory monitoring overnight.
What about the hypothermia risk we talked about in the NICU? Does anesthesia trigger that?
Yes, anesthesia blunts the autonomic nervous system. Because their brainstem already struggles to regulate body temperature, they are highly prone to hypothermia in a cold operating room.
So they get too cold.
Exactly. The surgical team must use active warming measures like forced air warming blankets throughout the procedure. And during recovery in the PECU, the prophylactic use of a nasopharyngeal airway, a soft trumpet-shaped tube placed in the nose down to the throat, is highly recommended to mitigate the risk of those floppy upper airway tissues collapsing.
That is intense.
It is. You, as the parent, must physically hand these printed guidelines to every single surgeon and anesthesiologist you meet.
You are the guardian of the blueprint. You have to be the squeaky wheel. Now, real quick, before we look to the future, what are the other minor subcontractors, the other specialists you'll see on an annual basis?
You'll be visiting ophthalmology. Visual impairments like strabismus, crossed, or wandering eyes and myopia are very common. Fixing these is vital, not just for quality of life, but so the child can actually focus on their visual eye gaze AAC devices.
Oh, that makes total sense. They need to see the screen.
Exactly. You'll also see endocrinology. There's emerging evidence that the PURA gene impacts the anterior pituitary gland, which regulates hormones. This can cause either delayed or precocious, meaning early onset puberty, as well as growth hormone deficiencies.
And gastroenterology.
Yes, finally, gastroenterology. Chronic constipation is near universal. The intestines are muscles too, and they suffer from hypotonia. They lack the strong wave-like contractions to move waste, requiring high-fiber diets, massive hydration, and daily osmotic laxatives.
Okay, take a deep breath. Let's step back. That is a staggering amount of medical management. It is overwhelming. And if you are crying right now listening to this, that is completely okay.
It is entirely understandable.
But we promised you at the beginning that this diagnosis is not the end. We've covered the heavy daily realities of the present. But what does the long-term horizon look like? Because when you hear the phrase ultra-rare disease, you immediately assume there was no money, no pharmaceutical interest, and no scientific research.
You assume you were abandoned.
Right, you assume you're on your own. But looking at the pipeline for 2025 and 2026, it seems like the science surrounding PURA is moving at absolute light speed. Why is PURA suddenly getting so much attention from the heavy hitters in science?
It's getting attention for two reasons. First, because the global patient community organized and mobilized in a way that is historically unprecedented. And second, because the biology of the PURA gene happens to be deeply fascinating to researchers studying broader neurological diseases.
That's amazing.
But before we get to the lab and the potential cures, let's talk about the human horizon. Let's talk about adulthood.
Right, because these babies grow up. What happens then?
Survival well into adulthood, into their 30s, 40s, 50s, and beyond, is the absolute expectation, provided that major medical complications like status epilepticus or severe aspiration pneumonia are managed.
So they live long lives.
Yes. As the first cohort diagnosed back in 2014 grows up into young adults right now, we are seeing this firsthand. They are living long lives.
But they remain dependent.
Yes. They will remain dependent on 247 care for activities of daily living. They will need help bathing, eating, and moving. This means parents need to start transition planning early, usually around age 12.
At age 12? That seems so early.
You have to start establishing legal guardianship or power of attorney for when they turn 18. You have to plan the massive logistical hurdle of moving from pediatric specialists who age them out to adult specialists. And you have to identify adult day programs that are equipped to accommodate nonverbal individuals with complex mobility and medical needs.
It's preparing for a marathon, a lifelong marathon of care. But while families are running that daily marathon, the scientists in the background are sprinting. Tell me about this research boom.
The years 2024 through 2026 are recognized in the rare disease community as a period of unprecedented activity for PURA, moving from basic biological discovery directly into the preclinical validation of targeted therapies.
Okay, so we're getting close to actual treatments.
Yes. To understand this, you have to understand the biggest bottleneck in rare disease research, the animal model.
Right. You can't just invent a drug and instantly give it to a human child. You have to test it safely. But how do you test a drug for a disease that didn't exist in medicine a decade ago?
You have to engineer a mouse that has the disease. And for years, scientists struggled to create a mouse that accurately mimicked the human symptoms of Pur-alpha syndrome. But in May 2025, there was a landmark collaboration.
The Jackson Laboratory and Jack's Tomorrow?
Exactly. The Jackson Laboratory, commonly known as JX, is the premier mammalian genetics institute in the world. They partnered with a fiercely dedicated nonprofit called Jack's Tomorrow. Using CRISPR-Cas9 gene editing technology, they successfully created a specialized knockout mouse model.
Let's explain CRISPR simply.
Think of CRISPR as a pair of programmable molecular scissors. Scientists create a guide RNA, a piece of code that acts like a GPS, which tells the Cas9 enzyme exactly where to go in the mouse's massive genome.
Okay, so it targets a specific spot.
Yes. The scissors go to the exact location of the PURA gene on the mouse chromosome and snip out a specific portion of one allele. They engineered a mouse that has functional haploinsufficiency, just like the patient's.
And did the mouse show the symptoms?
That was the breakthrough. The mice exhibited the foundational features of human PURA syndrome. They showed the profound motor deficits, the hypotonia, and crucially, the seizures.
Which means they finally have a biological test subject, a canvas to test cures on.
Exactly. And in parallel, researchers across the globe are utilizing these models. Look at the incredible work being done at the Florey Institute of Neuroscience and Mental Health in Australia by Professor Chris Reed.
What are they doing?
His research is a perfect example of how the community drives the science. His lab is heavily funded by the PURA Syndrome Foundation in Australia, which is directed by Mel Anderson.
Mel Anderson. Her daughter, Sarah, was actually diagnosed with PURA back in 2014, right? She was part of that pioneer generation that finally put a name to the Odyssey.
Yes. And that deep personal connection is the engine driving the science forward. In October 2024, to mark the 10th anniversary of the syndrome's discovery, Professor Reed didn't just stay in his lab.
He actually walked the Melbourne Marathon, right?
He did. He walked it alongside 90 participants, a mix of clinicians, bench scientists, and PURA families pushing wheelchairs to raise awareness and vital funds. And back in the lab, his team is using these mouse models to test novel therapeutic strategies, including something called gene overexpression.
Gene overexpression? What does that mean? How do you trick a gene?
Remember that individuals with PURA syndrome have one mutated copy of the gene and one perfectly healthy copy. The problem is that the healthy copy only produces 50% of the required Pur-alpha protein.
Right, the haploinsufficiency.
Gene overexpression aims to trick that one healthy copy into working overtime.
How?
By using viral vectors like an adeno-associated virus, or AAV. Scientists hollow out a harmless virus and pack it with a genetic promoter. They inject it, the virus sneaks into the brain cells, and it attaches an amplifier to the healthy PURA allele.
That is brilliant.
It tells the cellular machinery, don't just read this chapter once, read it 10 times. If they can ramp up the production of the normal allele, they might be able to restore the total Pur-alpha protein levels to normal, effectively curing the biological deficit and alleviating the symptoms.
That is science fiction becoming reality. That is incredible. But I have to ask the cynical question here. Even if Professor Reed finds a viral vector therapy that cures the JAX mouse, the FDA regulatory process in the United States is notoriously slow.
It is very slow.
Doesn't the FDA usually require traditional massive clinical trials with thousands of patients followed for 10 years before they approve a new genetic drug? How do you ever achieve that with an ultra-rare disease that only has 800 patients globally?
That is the ultimate hurdle, the brick wall for rare diseases, or I should say it was the brick wall. Because here is where the regulatory landscape fundamentally shifted in your favor.
Oh, really?
In February 2026, the U.S. Food and Drug Administration issued a massive, paradigm-shifting regulatory update. They released draft guidance aimed specifically at accelerating the approval path for individualized, ultra-rare disease drugs.
How does the new rule work?
The FDA recognized that demanding a 1,000-person trial for a disease that only has 800 patients is mathematically impossible and ethically wrong. The new guidance states that the FDA will now consider approving treatments based on evidence of a plausible mechanism of action.
Plausible mechanism, meaning if you can prove it works in the lab, they will listen.
Exactly. If researchers can demonstrate in robust preclinical models like the J-Scoliosis mouse, or in human cells grown in a petri dish, that a customized RNA therapy or CRISPR gene editing tool correctly fixes the specific genetic defect and produces the missing protein, that biological proof can be enough to greenlight the treatment for a small cohort of human patients.
That bypasses so much red tape.
It entirely removes the 10-year, billion-dollar clinical trial barrier. It opens the door completely for custom therapies for PURA syndrome.
That gives me absolute chills, because that means the research being done at the Florey and JX today could legitimately reach patients in years, not decades. The timeline to hope has completely collapsed.
Yes. But that rapid research only happens because of the community infrastructure the parents built. And this is the final and perhaps most important piece of the blueprint for a newly diagnosed family listening today.
Right. You are entering a fiercely dedicated, highly organized global family. The PURA Syndrome Foundation is the primary international body, and they are not just a passive support group, they are actively driving the science.
They created the Global Patient Registry in collaboration with the University of Southampton.
What does that registry do?
A registry is a longitudinal study tracking the natural history of the disease. Every time a parent logs in and updates their child's seizure frequency or their walking milestones, that data is pooled. It gives scientists the statistical baseline they need to prove to the FDA that a new drug is actually working.
That's incredibly powerful.
They also established a global biobank. They literally collect skin biopsies and blood samples from patients around the world, so researchers have physical human tissue to test drugs on.
But the foundation isn't just about the science, it's about the heart.
Yes, on the human side, they have built incredible tailored support networks. They have Grand POPS, a specific support group for the grandparents of PRA children, because the grief spans generations.
I love that. Grand POPS.
It's wonderful. They have sibling outreach programs for the neurotypical brothers and sisters who often have to grow up faster to help care for their sibling. And they have an ambassador program for one-on-one peer-to-peer parent support.
And let's not forget, October 23rd is Global PURA Syndrome Awareness Day. So as we wrap up this deep dive, I want to return directly to you, the listener. We know the piece of paper in your hand feels overwhelmingly heavy right now.
It does.
The life you envisioned when you were painting the nursery and dreaming about the future has irrevocably changed. But the life you are stepping into is not lesser. It is just different. It is a life filled with a profound, unspoken, deep connection with an incredibly loving child who understands so much more than the world gives them credit for.
Absolutely.
You are now part of a global scientific and family community that is actively moving mountains. You have the translation guide, you have the blueprint. You are not alone.
And I want to leave you with one final, deeply fascinating scientific thought to mull over when you look at your child. We spent a lot of time today talking about how vital the Pur-alpha protein is.
The foreman of the brain.
Well, recent biochemical research has revealed that Pur-alpha interacts with expanded genetic repeats in other, much more famous genes. Specifically, it heavily interacts with the C9orf72 gene.
Why is that gene famous?
Because mutations in the C9orf72 gene are the most common known genetic link to amyotrophic lateral sclerosis ALS, or Lou Gehrig's disease, and frontotemporal dementia. It also intimately interacts with the FMR1 gene, which is responsible for Fragile X syndrome.
Wait, I need to make sure I'm understanding this. The exact protein that your child is missing, the foreman of their brain, is intimately involved in the mechanics of ALS and dementia.
Yes. The Pur-alpha protein appears to play a foundational, critical role in the molecular mechanisms of these massive, well-known neurodegenerative diseases. Scientists are pouring money and resources into studying PURA syndrome right now, not just to help PURA patients, but because understanding exactly how Pur-alpha works might be the key that finally unlocks therapies or cures for millions of people worldwide suffering from ALS, Alzheimer's, dementia, and Fragile X.
So when you look at your child, you need to realize they are not just fighting a rare condition in a corner. Their unique biology is foundational to modern neuroscience.
It's exactly. The genetic research being championed by your PURA community today could literally change the future of global medicine, the diagnostic muddy waters you are standing in right now. They might just be the wellspring for a medical revolution that changes the world. Welcome to the family.